In this AstroPictionary concept video, we're going to go over end products of stellar evolution. Here we're looking at stars that are on the Hertzsprung-Russell diagram, known as the HR diagram. On the horizontal axis, we have the star's temperature, and temperature increases to the left. Along the vertical axis, we have the star's luminosity, and luminosity increases upward. Therefore, on the left-hand side, we have hot stars, and on the right-hand side, we have cold stars. At the top, we have very bright stars, and at the bottom, we have dim stars. From the upper left corner to the bottom right corner of the diagram, we have what's known as main sequence stars. Main sequence stars are adult stars that are fusing hydrogen into helium in the cores of their stars, or in the case of the very bottom right corner, they're stars that started out fusing hydrogen into deuterium, but they faded away or they stopped fusing. We divided up this main sequence, diagonal from upper left to bottom right, into segments because it's easier to understand stellar evolution from the adult phase. And we're not going to go through stellar evolution. We're just going to start with the main sequence phase and talk about what they die into, their end products. Now, if you look very closely along this main sequence, you'll see mass numbers that are listed. We know the masses of stars along the main sequence. So we're going to divide the main sequence up by mass into segments. Down at the very bottom, we have the VLMs for very, very low mass stars. Above that, we have very low mass stars, VLMs. Above that, we have low mass stars, LMs. Above that, we have intermediate mass stars, IMs. Above that, we have HMs, or high mass stars. Above that, we have VHMs, or very high mass stars. And above that, we have VHMs, which go off the diagram to the upper left. These are our very, very high mass stars. So we'll label them VHMs. So I'll just draw a diagonal going to the upper left to indicate that there is more to the graph, but this is all we could fit in on this graph. We want to know what these categories of stars on the main sequence die into. Let's start with the bottom right corner. The bottom right corner are our least massive stars, these VLMs. These are otherwise known as brown dwarfs. So I'm going to label them as BDs. Now, brown dwarfs are bigger than a planet, but not as big as a star. So I'm just going to draw a circle there to indicate the size that it is sitting on the main sequence as. Now, these brown dwarfs, especially the higher mass ones, start out fusing this hydrogen into deuterium in their cores, but eventually they just fade away and die off, just no longer fusing. So we think that these guys are going to have an end product of faded brown dwarfs. They started out fusing hydrogen into deuterium in their cores. Eventually they stopped because they ran out of material, and they just fade away over time. So we're going to call these faded BDs, or faded brown dwarfs, as the end product. And they're going to pretty much retain about the same size as they started out with. So I'm going to draw about the same size circle. Let's go to the next category up. These are our very low mass stars. Our very low mass stars are otherwise known as red dwarfs, or RDs for short. Now, these red dwarfs have not died yet, so we don't really know for sure what the end product will be, but we think that they're going to be white dwarfs. So I'm going to put a question mark before the W and after the D, because we're not sure if they truly end up as white dwarfs. We think they do, but we're not sure. Now, these objects on the main sequence are a little bit larger than the VLMs. So I'm going to draw a bigger circle out here where they were at the red dwarfs. So my circle's a little bit bigger for the red dwarfs. Let's go to the next category up along the diagonal, moving our way to the upper left. These are the low mass stars, and if you look closely, you'll find the sun's location in here as a low mass star. So we're going to put these as SLs. These are sun-like stars. And the sun-like stars are a little bit larger than the red dwarfs. So I'll draw an even bigger circle. And we know for sure that these die off as white dwarfs. So I'm just going to put WDs here because we know for sure they die off. Same thing is going to be the case for the intermediate mass stars. They're bigger on the main sequence, so I'm going to draw an even bigger circle. And these intermediate mass stars also die into white dwarfs. We know that they die into these objects. And these are just our IMs. Same thing with our high mass stars. We know what they're going to evolve into. Our high mass stars start out even larger on the main sequence than the intermediate mass stars. So I'm going to draw an even larger circle. And they're going to evolve into neutron stars. So I'll put NS's for neutron stars as their end products. And then lastly, we have the category of our VHMs and our VVHMs. And so we want to find out what these guys die into. These have so much mass that they're going to be even more compact than a neutron star. But they start out on the HR diagram as an even larger sized object in the main sequence. So I'll draw an even bigger circle. And these guys are going to die into our black holes. So I'll put BHs here for black holes. Now these are stellar mass black holes. Same thing with the VVHMs. These are our hypergiants, so I'll draw an even larger circle. And these guys are going to also die into our black holes. Now let's take a look at the N sizes. We started out with our brown dwarfs. Our brown dwarfs end up with about the same size as they started out. They don't fuse a whole lot and then they die out, so they generally retain most of their size. Now when we go to the red dwarfs, the sun-like stars, and we go to the intermediates, they're all going to die into white dwarfs, and we think the red dwarfs die into white dwarfs, and the size of this is about the size of Earth. So I'm going to draw an even smaller circle. So the Earth size, or the white dwarf, is smaller than the brown dwarf. So I drew my circle smaller than the brown dwarf. So that's the size of our white dwarfs. Now our neutron star is going to die in even to a smaller sized object. So I'm going to draw myself a small circle, and that's the size of a large city, such as Berlin in Germany or such as New York City in the United States. Black holes die even into smaller sized objects, so I'm going to put just a dot there because they die into the size of a small city, such as Toledo, Ohio. So we notice that we have a trend here with end products, and that is that size goes down. So objects may start out really large on the main sequence, but die really small as an end product. So let's take a look at these black holes. We have our supergiants and our hypergiants, and these are going to die into black holes. Notice how large they are on the main sequence. They die into the tiniest sized objects as an end product.